So, happy Friday, everyone. Welcome to the CI Engineering Brown Bag for today. Today, we're privileged to have Andy Lake from ESnet speaking to us. He's going to be talking about PSConfig, an introduction to PSConfig and perfSONAR 4.1. So I am going to hand it over to him. Take it away, Andy.
All right, thanks, Eli. Let me get fired up over here. So as Eli said, today I'll be talking about something called PSConfig, which is going to be new in perfSONAR 4.1. So perfSONAR 4.1 is not released yet. We're hoping next week, maybe-ish, we should have the first beta out. Basically, it's just about done. Been lots of travel and stuff the past week, so put the bow on a few things and push the package out, but we're getting close. So this is a preview of some of that work, and once that's out, you'll be able to play with some of the stuff I'm showing you. So let's hop into that. Oh, jumped on me. All right. So just briefly, I'm going to cover actually quite a bit of material today on PSConfig. So this is just one feature of 4.1. There's actually a bunch of other stuff that's in 4.1, but probably each of those things need their own topic, and this in particular does. So I'm just going to be covering this one feature. So if you've used perfSONAR before, you're probably familiar with the MeshConfig component. It's basically what people use to collaborate and set up their test meshes and build their dashboards that we see in various collaborations. So this is basically the new version of that. I'm going to kind of recap a little bit what MeshConfig is and kind of cover some of the details that you may not be aware of if you don't work with it every day, and kind of set the foundation for why we thought a refresh was needed. And then once we kind of establish that, I'll go into some of the basics of PSConfig and give some examples of how we can use it and some of the new stuff that it can do that we couldn't do with MeshConfig previously. And then I know just from questions I've got in other venues, there's lots of questions about backward compatibility for especially for those that are currently using the MeshConfig. So I will cover that and then wrap things up. So let's, I guess, hop into it. So MeshConfig. So for the MeshConfig, which is the current component, this is a diagram of the current 4.0 architecture. So the MeshConfig kind of lives in that orange box there. So if we go kind of from the bottom up, the bottom is the tools layer, where we have things like iPerf and the OAMP tools, OW ping and PalStream and ping and traceroute and all that stuff. On top of that is PSConfig, which was the big component we added the last major version, 4.0. That's responsible for kind of scheduling and executing all of those programs. And then it ships those results up to the archiving layer, which is primarily Esmond, but it can be other things, which is especially relevant when we talk about PSConfig a little bit later. And then kind of also sitting on top of PSConfig is this MeshConfig component, which basically can talk to PSCheduler and tell it what tasks needs to be set up, and then likewise it can talk to maddash and based on those same tasks, build some dashboards that display, kind of summarize those results and give an easy display to that. So that's kind of where we're sitting when we talk about this. So MeshConfig has been really important to perfSONAR, I think. Since its introduction, I don't know if it's been 5 years or something like that, somewhere in that ballpark that we introduced it. I think it's a really kind of a distinguishing factor of perfSONAR from other kind of similar measurement platforms, in that it basically enables kind of this collaboration that perfSONAR is known for, right, between institutions. It's a pretty simple idea, right? Throw a file up on a web server somewhere, point a bunch of hosts at it, and kind of have it tell them what to set up, and use that to also build visualization. But it's been a very powerful one. So MeshConfig has been very important, and we don't want to lose all that good stuff. But since we've introduced it, we've learned a lot, and perfSONAR has changed a lot. So basically, with kind of all that in mind, we started thinking it was time for a refresh, and I think that'll become a little bit clearer too as we look at some of the details. So MeshConfig, again, just as a recap, actually has two main components. The first main component is what we call the MeshConfig agent. So this is the piece that actually talks to pscheduler and sets up the tasks that need to be run, the measurements that need to be run. So the way the MeshConfig agent currently works is we have these JSON files that, like I said, live on a web server someplace that it reads in, which tell it kind of what task it wants to be built. Now those JSON files are generated a couple different ways. I think the way most people do it is the one over on the left here all the way, where basically you actually first have a different file format that's not JSON, that kind of looks like an Apache web server configuration. In Perl lingo, it's config general is the library that parses it. Basically, you define your tasks in that. Then you run it against a script called build.json, which converts it to JSON, and then you throw it on a web server somewhere and point things at it. There is another option that I think mainly like the OSG and WLCG uses because they were kind of the original developers of this. There's actually a graphical interface that's in beta that can generate the JSON directly from MeshConfig as well. And then also a lot of people use the toolkit GUI. So when you install the ISO or yum install perfSONAR toolkit, you get the perfSONAR web interface and go in and set up tests. So a lot of people use that. That actually doesn't generate the JSON though. It generates a third format, which is known as MeshConfig agent task.conf, where it kind of stores the task you want run. And in fact, the MeshConfig agent actually, when it reads the JSON, actually converts to that MeshConfig agent task.conf, then reads it back in and talks to pscheduler. So we basically got 3 configuration file formats here we have to deal with, and if that seems overly complicated, again, you're starting to see the, the reasons for why we're doing this refresh. So the other component of MeshConfig is called the MeshConfig GUI agent. So this is the part that talks to maddash. It works very similar to the pscheduler agent in that it reads JSON that can be generated those same ways. It reads the same JSON file. And then spits out what's called maddash.yaml, which is the main configuration file to maddash. So one thing that's different about it is that concept of the MeshConfig agent task.conf file is not in the GUI agent. So for example, if you wanted to build a dashboard directly from what you generated with the toolkit GUI, you can't do that currently. Now, maybe you don't want to do that because it would look like one host. It would kind of just be a single row, right? But it's not even possible just because of all the configuration formats we have and the way things all connect together. So from a developer perspective, these 3 configuration formats too, whenever we want to make a change, like if we add a new option to a tool, or we add a brand new tool plugin to pscheduler, or we add a different way to archive the results, we have to change that 3 places. We have to document that 3 places, and all that stuff, which is complex and prone to errors each place we do it. So I'm getting a little bit of feedback too. I don't know if somebody is unmuted. So
yeah, let me see if I can mute folks here. Sorry, Andy.
That's okay. All right. All right, that sounds better. So like I said, there's a lot of good to the MeshConfig, right? It's been very successful for us. The overall model of having kind of this central way to define tests that everybody can look at and do things has been a good thing. There's some options for manually setting some parameters locally and things like that are useful. And overall, there's a lot of good to like about MeshConfig, but there's also some bad. Which is, all those configuration formats I mentioned, which creates a relatively complex process. And as I already mentioned, it's kind of hard to have it keep up as we make changes and add new tools and capabilities, which is now kind of a bigger issue now more than ever, that we have kind of the pscheduler framework, which makes it really easy to do that. Even outside of the core development team, people can do that. So we kind of got all these challenges, and then what I like to call the ugly. If you actually look at the syntax of the configuration format, it's kind of a mess, particularly because it uses a bunch of outdated terminology like perfSONAR buoy, which if you've been using perfSONAR for maybe 7 or 8 years, you remember that term. But that's a component that hasn't been around forever, and it's littered all over the place. And yeah, it's just basically kind of a confusing format in general. So with all that in mind, let's kind of look at PSConfig. So PSConfig, if you look at now the 4.1 kind of architecture diagram, it's sitting in the same spot as MeshConfig, kind of in this orange layer. If you look closely, you'll notice probably a couple other changes to this diagram. Like I said, there's a couple other features that won't be covered, but it's sitting in the same spot as MeshConfig. So when we set out to write PSConfig, we had a few goals in mind. One is we wanted to consolidate those configuration formats. We just want one format to kind of do everything. So we don't have 3 places where we're trying to juggle things, because I think it's confusing for both developer and user alike. Another big requirement was when we make changes like add new tools or options or archivers, we didn't want to have to change the code. We don't want to have to release a new version of PSConfig every time somebody writes a new test plugin or something like that. I think we want everything to be kind of plug and play, so we want that to work right out of the box. Also, pscheduler does a pretty good job of normalizing a lot of terminology like task and test and archiver. If you read the documentation, so we want to be consistent with that, right? So that way, when we're talking about different components of perfSONAR, we're talking about them in the same way. I want to streamline a little bit how things are published because we get lots of questions about that. And then perhaps one of the biggest things is the documentation. I think that's long been a complaint about MeshConfig, is that it's lacking in certain areas of the documentation. And I think a large part of that was actually due to some of the complexity. Some of it was just kind of hard even for us developers to document and pull things out and figure out what it's doing. So we kind of wanted to correct that. And then kind of the final piece is for those upgrading, we really want to make the transition from MeshConfig as painless as possible. So those kind of our goals we had in mind when we set out. So kind of moving along, let's kind of look at some of the foundational concepts behind PSConfig that we put in place once we started designing this. So kind of our first and most important definition, right, is what is PSConfig itself. This slide, we have PSConfig defined as PSConfig is a template framework for describing and configuring a topology of tasks. So there's a couple terms in bold there that I'd like to kind of look at a little bit closer. So we're actually going in reverse order. So tasks. So task is basically just a job to do. And if this definition sounds familiar, that means you've probably been doing your PScheduler homework, because this is the exact same definition of a task that PScheduler has. And so in PScheduler, tasks actually consist of multiple kind of subparts. One is like the test, which is like the actual parameters of the test to run, and like the type, like throughput. So like, the test would contain a type, throughput, and then some parameters might be source, destination, and duration, or something like that. There's the tools that actually execute the test. So again, using the throughput example, that would be like iperf, iperf3, or NutTCP. There's a schedule associated with a task, which is how often you want it to run. There's archiver, so basically where you want to ship the results, like asmin, or there's actually some other options for things like syslog and RabbitMQ. And then there's actually something called context, which isn't even a concept in on the old MeshConfig, and was added, I think, last November to PSConfig when we did 402, which is basically some like initial setup that you do prior to running the tasks. The best example we have right now is setting up like a Linux namespace. So it's kind of got all these concepts associated with tasks, and we want to carry those over to PSConfig. So just the list of tasks though themselves is not, we need more than that, right? We also need to understand the relationships between those tasks. In particular, just so we can draw the dashboards, right? So, PSConfig wouldn't be good enough if basically it just generated a list of, I want to run from Lawrence Berkeley Labs to, Brookhaven Lab and, maybe 4 other places. And then I have, an Oak Ridge testing to the 5 same places, right? I kind of want to probably relate those things so I can put them in a different dashboard. So that's kind of where this concept of topology comes in. It's not really intended to be too complicated, more complicated than that, but basically just capturing the relationships between tasks is an important thing for PSConfig. And so then we want to basically express this relationship between the tasks, this task topology, in something. So we call that a template, right? So that's basically a machine-readable file that describes your task topology. And so a lot of people in MeshConfig call these mesh files. I assume people will continue to call them mesh files, and that's fine. Kind of in PSConfig terminology, I've kind of switched to calling them templates just because I think mesh kind of implies full mesh and things like that. But so templates is kind of the terminology I'll use throughout. But you could replace mesh file in with that if you prefer, and it's basically the same idea. So kind of the last concept is if we have these templates, now we actually need to do something with them. So an agent is software that reads one or more of these templates and then performs some specific function. So very similar to MeshConfig, we currently have two agents. One is called the pScheduler agent, which its job is to talk to pScheduler. So this would be equivalent to what MeshConfig called the MeshConfig agent. Hopefully a little bit clearer name as to what it's actually doing. And then likewise maddash agent, which talks to maddash and sets up your dashboards, which again is the equivalent of the GUI agent in MeshConfig. Again, hopefully a clearer name. So then in terms of building these templates, and that's kind of what I'm going to walk through next, we need a few other kind of concepts beyond kind of what like pScheduler has and things like that, because we're kind of building a whole bunch of these things. So the most fundamental concept that you'll find in PSConfig is something called an address. And I threw around a lot of different names for this, and I can't say I love this, but when we actually go through like host examples, it kind of relates, it maps pretty well. And but basically it's just an object with properties. It doesn't necessarily have to be associated with an interface or anything like that. It's just a pointer to something that has properties. And so an address is kind of our most basic concept. Then we want to group these addresses together to kind of capture those relationships I was talking about. So a group is basically how we combine these different addresses. So there's a concept of that. And then last, we have this thing called template variables. So when we're building our tasks and things like that, we're going to want to pull out bits and pieces and fill them in different places. And so kind of we use these things called template variables for that. So let's kind of look at that in the abstract real quick. And kind of help give a better idea of what's going on. So we can think of addresses as these three shapes right here, right? So all these shapes have properties. They're circles. They all have different colors. There's blue, red, and green, and so forth, right? So let's say we have these three shapes here. And then we want to group them together. So that's where the concept of groups comes in. So there's a few different types of groups. And again, if you're familiar with MeshConfig, a lot of this will sound familiar. So one type of group is type mesh, which means take an input of all these address objects and pair each of them with all the other ones. And order matters in the case of this mesh. So we have, blue, red, and we also have red, blue, things like that. So, in this example, if we have these three shapes, we end up with 6 pairs shown. So that's type mesh. Another type, again, probably familiar from MeshConfig, is called disjoint, where you have maybe 2 groups of these address objects. One we call your A addresses. So in this example, there's just the blue circle. And then your B addresses, which has the red and green circle in this example. And then we pair every A address with every B address. And again, order matters in this example. So you have blue, red, blue, green, and then you also have blue as the second item in the pair. Now, you can actually control that with a different option in PSConfig, which is probably a little bit outside of the scope of this presentation, but you can set an unidirectional option, so it would just give you blue, red, and blue, green. But that's basically disjoint. Then we have a new one in PSConfig that does not have an equivalent in MeshConfig called list. And this is actually just a one-dimensional group where basically it takes the input addresses and spits out the single items. So not to get too ahead of myself, but kind of part of the motivation for this is if you have something like an SMP test that's just creating a single interface as opposed to a source destination pair, you really just need one address. So this kind of allows you to just kind of iterate through things. You can now also imagine groups that spit out things that are greater than 2 items. We don't currently have one of those, but things are written in such a way that that's not going to be difficult to add in the future. So that is in the back of our mind, but that is not here yet, which we don't have any tests that actually support that yet. So that's kind of why that was deprioritized. But that is something that I imagine we will have in the future. So we have these address objects. We can throw them into groups. Okay, so now we want to input these groups into something and build our tasks. So this is kind of a visual representation of a task, right? And so like I said, it has a bunch of different components. One is the test, which is kind of this dotted box. And the test has a couple parameters. In this case, the parameters are going to get filled in with this idea of template variables. So there's kind of these placeholder squares right here. And then the template also has a schedule and an archive. In this example that are represented by those items. So now let's kind of bring this all together and see, this is essentially, the fundamentals of what PSConfig is ultimately doing. So it's taking this group of addresses, it's pushing it through a group. In this example, I just took the mesh group. So then it's creating these 6 pairs. And then for each pair, it's running it through our task template. And since our task template has some template variables, it's pulling out the property. So in this case, the color was the property getting pulled out. And then when you're all the way over here on the right, you basically get our list of final tasks, right, with all the colors filled in and all that. So abstract is nice, but probably a real-world example might relate more for some of you. So let's say we now have an example where we have these 5 hosts. So the top host there, admin.archive.perfSONAR.net, is just that. It's just an admin archive that's going to store results. It's not going to run any measurements. And then we have these 4 hosts down below that are going to be running various combinations of throughput and latency and have different numbers of interfaces. So starting all the way over here on the left, that one.perfSONAR.net has a single interface. It's going to be just running a latency test. The second host has a single interface. It's just going to be running a throughput test. The third host here has a single interface, but it's going to run actually both throughput and latency out that interface. And then a fourth and final host over here actually has 2 interfaces. One it's going to dedicate to latency testing, and one it's going to dedicate to throughput testing. So let's look how we'd actually build a real JSON template with a setup like this to run basically a set of throughput tests and a set of latency tests. So first, just like we did with our circles, we need to define our addresses. So in this case, our address objects are actually the interfaces of the hosts. So the way that ends up being structured is you have these JSON objects that you name, and the name can be anything. We could have repeated the address if we wanted to. I use the short form name. It's just a string. You're going to use it to reference it in other places of the template. So that's really all that's there for. And then they have this address property where it's basically just an identifier for the object. But in this case, we'll use the host name to identify it. Now, I will say, this is like as simple of an example as you can. There are other properties. There's a thing I couldn't figure out how to fit in with the time I have called meta, this property where it's basically an opaque JSON blob and you can add custom stuff in there. So there's a lot of cool flexibility here, but this is kind of the basics. So basically, each of the interfaces on the host have their own address object. Now you'll notice lat2 and trhr2 are actually on the same host in real life. If we look at our picture, but that fact is actually not captured in the addresses. That's kind of irrelevant to the addresses. Now we do actually have a way to capture that relationship. There's a hosts object where you can kind of say they both belong to the same host and add some common set of properties if you need to. Now for this example, it doesn't actually really add anything, so I didn't define that, but just so people know that option is there if you so desire. So those are our address objects. All right, so then next is our groups. So we have 2 groups, basically the group that's going to run throughput tests and the group that's going to run latency tests. So we specify a type. Again, I'm just going to do mesh. I could also do disjoint here if I wanted to set things up a little bit differently, but we're going to do mesh so everything's testing to everything else in that group. So we put our 3 throughput interfaces in there. We put our 3 latency interfaces in there and the latency one, and have our groups. We'll notice the common one is the one that's running both. So it's in both groups. So I think that's pretty straightforward, hopefully. And then we have our tests where we actually define the test parameters we want to run. So first we need a throughput test. So if you actually look at these objects, to PSConfig, these are actually completely opaque. It doesn't really know anything about these objects. It's going to rely on pscheduler to validate them. So that's kind of where how we reach our goal of not having to change the code every time we add a new test, right? So basically, PSConfig knows there's this object here, and it's going to kind of be relying on pscheduler and the plugins it has installed to kind of validate these tests. So we have a test object, and it has a type, which is throughput. Again, that matches up with how pscheduler wants a throughput test defined. And then it has these parameters. Now we'll notice the source and dest look a little interesting, right? They have these weird strings. So anything between kind of these curly brackets and percent signs is actually a template variable, which I talked about earlier. So there's a few different types of template variables. This is probably the most common one people are going to be used, at least out of the gate, called address is the template variable, and then it kind of has this array index. So basically address 0 means take the first address in the pair. So if we had our circles, there was like 2 circles, this would take the first circle. But in this case, since we're using host names, it's going to take the first host name that's assigned to the address. And then dest index 1 means take the second item in the list, so that's going to take the second address and plug it in there, right? So we're basically fully kind of defining our tests and then pulling in the pieces we need to build that specification. Likewise, latency uses the same variables and has a couple different parameters that apply to latency, and that's what we have there. And so then kind of just moving on, the rest pieces of a task, we also have schedules. So this one means, run every 4 hours. Again, it's using kind of the pscheduler construct for how schedules are. And actually, I should say this is actually every 4 to 8 hours, right? So repeat every 4 hours, but allow it to slip up to 4 hours and randomly slip it. So it'll randomly run every 4 to 8 hours, actually is. So it should probably actually have a longer name, but that's what that one means. So then we get final piece is to actually bring it all together. So we have a tasks object where we name each task. And then we basically define our group. So that was the name we assigned our group earlier. That's just a reference to that. We have our test. We have our archive. Did I miss the archive? I did. Sorry, my screen keeps, sometimes I move forward and Google doesn't show the doesn't show the slide. So there's also this archive object too. And again, this is taken from pscheduler. Pscheduler is responsible for validating this. So one of the plugins is an esmin plugin in pscheduler. So we specify archive or esmin, and then we've just specified the URL here. There's other options, but for the simple example, we just put in the URL. So that's what this is referencing. Sorry that got skipped. And then the schedule is referenced here every 4 hours. Now for our latency task, we actually don't have a schedule because that just runs constantly. So you don't have to specify one of those. That's how it kind of is specified in pscheduler as well. So that's how we kind of bring everything together. So that's basically the template, kind of the basic ideas behind the template. So now let's actually start looking at what we do with templates and things like that. We have this JSON file. Now we want to kind of publish it somewhere on the web. So we actually have a few different options in PSConfig. So before, option 1 was actually, just about your only option with MeshConfig, which is to manually copy it somewhere to a web server, which you can still do. Now, we got a lot of questions about this. It was almost like too much freedom about people just weren't sure where to put it. They'd ask, what to do with their ultimate JSON file, and we'd say, copy it to a web server, and they'd be like, well, yeah, but where did I put it? So we wanted to give a couple other options so it was clear, so people kind of had a little bit more directed path if they wanted it. So that's kind of where option 2 comes in. We have this new command called PSConfig publish that'll actually copy the JSON to a well-known location. And also do some things like validate it and such before it does that, just as kind of a convenience for people that want to publish this and kind of want a solution that's kind of already baked for how to organize where the templates go. A third option is, so I think I mentioned earlier, the MeshConfig GUI that exists that only a couple people use. Part of 4.1 is a refresh of that to work with PSConfig, and that's been renamed PSConfig WebAdmin. So you can also build things there, and then it kind of has its own methods for publishing the JSON. And then last would be to manually copy the template on the local file system of the agent. So there's like include directories in the agents, which I'll go over in a little bit more detail momentarily, which was not an option before in MeshConfig. So that's another way to get it to the agents is copy it on the local file system and like one of those include directories. So let's just look at an example of the PSConfig publish command, which was option 2 that I talked about. So let's say we have this file example.json. So basically what I can do is run psconfig publish example.json, and then I'll basically it'll validate the JSON to make sure everything looks good. If it doesn't, it'll tell you so, and it'll throw an error back, trying to give you a pointer to what it thinks is wrong with the schema. But if everything looks good, it'll give you output like this, and it'll say file saved to this directory here. And then it'll say the published file can be accessed at this URL. Now, if you actually run this on your host, it'll actually try and fill in host name here. And then it has this last thing that says execute this command on something running the agent to actually have the agent use it. So this is a command called PSConfig remote, which I'll be looking at a little bit closer in a couple slides here. 2, I have a link down here at the bottom. All this stuff is documented at that link, so if you want more details on PSConfig publish, that's there. But that's just basically the kind of basic idea how that command works. As I mentioned, so PSConfig WebAdmin, this is just a sample of one of the pages. It also has its own method for publishing these. It's kind of cool. It can do some more advanced stuff. So like, let's say you have this WebAdmin and it's controlling a bunch of different hosts and is controlling a couple different meshes. So you can have the host actually point at the different meshes separately that it belongs to. It also has a way to basically give a customized URL for a host. So you don't have to point multiple places. You can just point at kind of one URL, and if it's in 3 different meshes, it'll just kind of merge all of that into the template that it's reading. So the PSConfig WebAdmin is probably a presentation on its own. So this is the only slide I have on that, but that is something that's going to be available in 4.1 that people can play with. So hopefully that gives you a flavor. So that's kind of a flavor for some of the publishing. Now let's kind of jump into looking at a couple of the agents and what they can do. So first, the pScheduler agent, which I think I've said multiple times now is the thing that actually talks to pScheduler. So this kind of is talking about what it's responsible for, some interesting bits. So notice number 1, reading and modifying templates. That's actually something that's a little bit new that I will get into. So you can actually do some cool transformations and things locally to the templates before you start setting up tasks. It has to make some decisions about what tasks the agent is going to create. Generally, it's based on it auto detects the addresses on the local interfaces, and any task it determines that have an address that matches that local and those local interface addresses is what it does. So that's basically the same as MeshConfig. That can also be overridden with configuration options, and then talking to pScheduler. So. Yeah, this is a diagram of that. Again, pretty clear. Suck in the JSON from the various sources and talk to pScheduler. So in terms of actually using the agent, so you have the pScheduler agent installed. Now you need to point it at a template somewhere. So there's basically 2 different types of templates. There's remote templates, which are JSON files that don't live on the same host as the agent. So usually you're going to be supplying a URL in that case to the agent. And the most common way to do that is with something called the PSConfig remote command that I kind of alluded to earlier when talking about PSConfig publish. The second method is local templates that live on the agent's local file system. And you can either use the PSConfig remote command to point at the file path, or you can actually copy it to some include directories. So let's look at both of those in a little bit more detail. So remote templates. So here's a couple example commands. So the kind of most basic one is psconfig remote add and then give it a URL. And that will add the URL to the agent's kind of configuration file. Now, there is a configuration file backing all this, so if you want to manually update it, you can. But the idea is you don't have to anymore, and that's going to save you from syntax errors and things like that affected people. Also, just adding the URL isn't necessarily the only option that's available for setting. So, for example, we've kind of carried this concept over from MeshConfig. We kind of debated whether or not to do it, but I think ultimately it's probably the right decision. Is by default, when you add a pointer to a template or mesh file in the old days, if there's any archives defined in that remote file, it doesn't automatically use them. You kind of got to opt in before you kind of just let some file you read out there start shipping your results someplace. So to do that, you had to set an option called configure archive. So now there's like a command line switch for that. And just in general, kind of one nice thing about this kind of CLI approach versus just editing configuration file is you have this kind of psconfig. You can always use a -- help, right, and get a list of all the options. Or if you mistype something, it'll tell you right away and things like that. So this is kind of a little bit new way to add things. And we also have this command psconfig remote list. If you ever want to kind of look at what templates you have configured, I can do that. We also have a psconfig. It's not shown, but there's a psconfig remote delete if you want to remove an archive and things like that. Another nice thing is it'll also prevent you from like adding 2 of the same URL. That's been a problem for people before, which that would actually get caught by the agent now as well. But it catches a lot of things like that basically when you're just editing a configuration file directly, like in MeshConfig, didn't get caught and created some headaches. So then in terms of local templates, like I said, you can actually use the psconfig remote add command and just give it a file path instead of a HTTP URL. And it works just the same. Or now you have this option to copy it to an include directory. So this is kind of cool too, we think, especially for places that run, Ansible or other configuration management stuff, generally those pieces of software are good at dropping files and directories. So if you're, defining some tests that way or something like that, that should make life a little bit easier, hopefully. And I guess it should also be mentioned, like the toolkit GUI, it actually is editing a file in one of these, in that include directory, things like that. So kind of gives you some new options there. So in terms of, okay, so we've got some templates set up, and we started kind of reading these templates. So one thing, and you could basically do the equivalent of this in MeshConfig, is you might want to define some archives locally. So maybe either you didn't set that dash configure archives option, or you have like an additional archive that's not in the remote template that you want, where you want your results stored. So basically now there's a directory, this archives.d directory, where you can drop these archiver specifications and it'll automatically ship them there. So the example here actually demonstrates one of the most important things about PSConfig, which is in MeshConfig, you could only ever write to Esmond. In PSConfig, you can use anything pscheduler supports. So it has a syslog archiver, right? So basically, if I wanted all my results to be written to, the local SIX facility and my local syslog at the info level, I could drop this in, and it would do so. So kind of a cool new feature that you can do in PSConfig. So this is definitely an advanced topic, and I imagine most of you won't be doing this type of thing, but I just want to highlight that you can do it. If you've been following pscheduler, there's a lot of things you can do with this kind of scripting language, I'll call it, called JQ. Mark Fight, who's on the call, actually did a good webinar on JQ a few months ago. That's on our YouTube channel. But basically, you can drop in these little JQ scripts, and before you do anything with the template, you can actually do some transforms to it. So for example, I have this little script here that basically grabs an archive out of the archives section. If there's one called example archive central, then basically it sets this field called auth token, which is where you set the API key to talk to Esmond, to ABC123 in this example, but in practice you'd actually use your API key. So basically this gives an option for people. Before, if you were using the dash configure archives option and setting archives from remote mesh, you had to use IP address authentication on your archive, your Esmond server. Now, if you wanted, you still have to drop a file on the local file system, but you could drop a file like this into the system to actually set an API key and still manage at least the URL and stuff in the remote file. So this isn't the only type of thing you can do. You could also do things like if you need a certain set of OAMP test ports for every OAMP test, you could write a little script to do that. We have some examples in the documentations of that, the ship. And basically anything you can think of to do the JSON, you can actually do now. That's kind of a cool new feature. There's two ways to add this. Again, there's an include directory called transform.d where you can just drop these JSON and that'll transform every task that comes through, or at least apply the script to it. Maybe the script will ultimately not make any changes, but you can do that. If you want just the script to look at a single template, you can actually use the PSConfig remote add command, and there's this dash transform option that you can either give the JSON directly, or you can use the @ symbol and put a path to the file like that. That actually is consistent with a few ways that pscheduler commands do handle this kind of JSON stuff. So that's kind of one of the more advanced options. Another thing we were kind of seeking to improve is troubleshooting. So we've made all the logs in a parsable format now. We've kind of split up the logs too, so it's easier to navigate, and written a few utilities that actually parse the logs for you. And I'd actually like to add a few more when all is said and done to make things a little bit easier. So we have this one log that has just your basic information, errors, and things like that. It's probably kind of your first place to look when things go wrong. And then something that tracks all the tasks that PSConfig thinks it should be creating, which is sometimes useful for comparing to what you're actually seeing. If a task isn't showing up or you're not getting results, it's good to be able to ask if PSConfig even thinks it should be configuring it. And then this transaction log that logs every interaction with pscheduler, which is really useful for getting down to the nitty gritty. And so then there's a couple of utilities that read those, like this pscheduler stats command that tells you kind of when the agent last run and the templates it looked at and how many tasks it got from each template and things like that, and then the tasks that basically format the interesting information from this task.log and print it out for you. So there's a documentation section on troubleshooting at that link there for more information on those. Then real quick, let's look at the mad-agent because I want to save time for questions at the end. Again, the mad-agent is very similar to the PSConfig agent, except it ultimately is spitting out the mad-dash.yaml. Probably the most interesting part, and what I'll focus on is this number 2, is how it determines what to display when it sees a certain set of tasks. And you have a lot more control in PSConfig versus what you did in MeshConfig to do different things and show tasks in different ways. So let's look at some of that. Yeah, there's a visual representation of that. I think, again, we've probably beaten death to death at this point. So there's that. In terms of configuring templates, so telling the mad-agent what templates to look at, it's exactly the same as a PSConfig agent, except there's a different include directory. It's mad-d instead of psconfig.d. You use the psconfig remote command still. I guess one caveat is if you actually have both agents on the same host. By default, PSConfig remote will just add the template to both agents. If you don't want it to add it to both agents, you can add this -agent option and tell them which one you want it to add to, and it'll do it. All right, so mad-agent actually has a couple more kind of concepts that it needs in terms of figuring out what to actually show on the screen and tell mad-dash to show on the screen. So kind of its most basic unit is something called a grid. So a grid is basically saying, okay, I see this task, like a throughput task, and it has a certain set of properties. What do you want me to do with it, right? So there's kind of two parts to the grid. There's the check, which it instructs the grid how to analyze the results. So like for throughput, it wants you to look at the throughput event type and compare that to some threshold that's based on gigabits per second or whatever the unit is. And then once I have those results, and that's basically how you get your red, yellow, blue, red, yellow, green in a mad dash. And then in mad dash you can also click on a box, right, and get a graph. So that's where this visualization piece comes in, right? So basically instructions on how to build a URL that gets the visualization, the graph you want when you see a particular type of task. Hopefully the terminology probably makes it seem more complicated than it is. So when you install the mad-agent, if you're installing it for the first time, you get a default set of things. So you might not even have to touch a lot of this. But basically how you add these grids and give it instructions for how to display things is through this psconfig maddash-grid command. So kind of the most basic one is here up at the top, where you give it a name, which again, this is just an identifier if you want to make changes later and stuff like that to identify it. Then you specify a check type and a visualization type. So there's a bunch of these plugins that are really just kind of like JSON descriptors, so it's pretty easy to add new ones. So this one's PS Nagios throughput, so that runs the standard perfSONAR Nagios throughput command that has backed mad dash since its inception. And the visualization type there's this plugin called PS Graphs, which generates URLs for the kind of standard perfSONAR line graphs that you've probably all seen. So these plugins, there are commands to list them. If you mistype them when you do this command, it will say, I don't recognize that plugin. Here's the ones that are valid, things like that. So again, this is helpful in debugging stuff. Also, it's probably worth noting that there's some that in MeshConfig, basically everything, all of this was hard-coded, right? So a lot of it you probably didn't even mess with. And again, like I said, there's a lot of defaults here. Have to mess with it. But if you've ever gone into MeshConfig GUI-agent.conf, it's basically a improved version of that, where you basically you could set things like the name of the dashboard and like what thresholds you want and things like that. So that's kind of this concept, but expanded a little bit. So if you look at this second example, it's the maddash-grid edit command. So I can edit that grid I just added if I want to change the threshold, and there's command options for doing that. So this 6 and 8, this is actually gigabits per second. It'll actually depend on the plugin that you're using. So the PS Nagios throughput is gigabits per second. So It knows that. If you want more details on what a plugin is doing, you can. There's actually commands. I don't have those here. They're in the documentation that give you more information on the plugin. So that's kind of all command-based and hopefully a little bit more self-documenting than things were in the past. Just kind of one cool quick aside is like a day or two ago. So before you always did this, if you wanted like different thresholds for different grids, you had to basically specify the name of the grid, and what name to actually use was kind of confusing. So we were actually redoing our development dashboard, and we have a bunch of UDP throughput tests, and we kind of changed the names and things like that, and then we weren't getting the right thresholds that we had wanted to apply to the UDP tests. And we were basically still selecting by name because you can, and it was just kind of the converted version of what we had previously in MeshConfig. But actually in PSConfig, we have a bunch of new, more advanced selector options that aren't shown here, where you can do things like, say, any throughput test I see that has the UDP parameter set to true, use this set of thresholds. So we were able to do that, and so now if we change our grid names, we will still get that threshold, or if we add a new UDP grid, we'll get that threshold. And again, this is all documented, and there's lots of options here for how you do grids. It should also be noted too, like some of the plugins, like we have like PS Nagios retransmits, right? So if you wanted to build a retransmits graph or retransmits dashboard or something like that, that's something you couldn't do before, even though we've actually had that check for quite a while now. So there's a bunch of different checks like that you can now apply and do multiple different things with tasks rather than just be limited to one particular type. And then there's, you can list all the grids that you have defined, and there's also help messages for all the options, and there's actually quite a few for this command. But hopefully that gives you a taste of what we're doing. Then troubleshooting, again, is very similar to the pscheduler agent. We have there's only a single log file just because it's not doing as much as the pscheduler agent. And we have this maddash-stats command, which spits out output like this. It tells you when it runs. It has this globally unique ID, which is actually used in the logs just to help you grep through the logs. If you grep using that, you'll get stuff just associated with this run. And then information about like the number of grids defined and where the different grids are the different tasks that are getting turned into grids, basically. So that's basically the two agents. Again, there's like a lot of detail there, and each of those are presentations in and of themselves, but hopefully that gives you a taste for things. So then I just quickly want to talk about backward compatibility. So this is probably the slide that if anything goes wrong, people will be throwing back in my face. But the idea is basically you really, on day one, when we release the final version of 4.1, and if auto updates kick into place, you shouldn't have to do anything. So the agents are actually fully capable of reading the old MeshConfig JSON files. So if you already have a system that's pointed at a MeshConfig file, and that MeshConfig file doesn't live on the system, right? So it's going to upgrade, and that MeshConfig file is JSON file is going to stay the same. And that's perfectly fine. The new agents will be able to read it. They'll internally be able to convert it and set up your tasks just like they did before. So that should just work. And in our testing, that's working well. And I'm sure as we do more betas and stuff, it'll probably work even better. So that's the current plan. So day one, you shouldn't have to do anything. So then the other piece of that is, okay, you actually are the one, who needs to update this mesh file and convert it to a PSConfig template. So basically, once all your agents have upgraded to 4.1, or you need a new feature that's only in PSConfig, then you'll want to start using a new format, and you can convert to the new format. We have a PSConfig translate command. Basically, you give it the old file, and then if you don't give it any options, it'll spit that to standard out. You could redirect that, I guess, if you wanted. Or there's a -o option where you can specify the new file that you want, and that'll translate everything. So again, it's probably out of scope for here, but there is some special behavior related to an option called force bidirectional. If I post these slides, I actually have some bonus material after the end that goes into that a little bit more. But there is some special treatment there, so be aware that it's kind of documented. It fully supports it, but basically your dashboards might look a little different than they did before, is what it comes down to, and it's for the better, whether you're aware of it or not, because force bidirectional did some really weird stuff in MeshConfig that was non-obvious. So be aware of that, but that's basically the process for converting from the old to new. And so then that wraps things up. And good, we have a little few minutes at least for questions. So like I said, the 4.1 beta is coming really soon. Hopefully that's next week. That's still just a beta. So when that comes out, like, all your production hosts aren't going to be upgrading. You still have a little bit of time for that. And we'll be sharing more on the user list and all that about, the upgrade process and some of the other aspects to it. When it does go live, there'll be no immediate action required because, things are backward compatible. So hopefully that goes smoothly for people. And then, yeah, I guess just overall, PSConfig is trying to, learn from MeshConfig and really set us up well going forward for adding new things and supporting new tools, some of which we have in 4.1. And basically everything I talked about here and a whole lot more is actually already documented on our 4.1 beta documentation. At that link, that's right there. That'll take you to kind of the main page and jump you down to the part with a list of PSConfig pages. So all of those have up-to-date information. There is one page on kind of this auto configuration, advanced pulling stuff out of the lookup service and things like that. That's still under construction and it's marked as such. But everything else from using the agents, a lot more details on the templates, and basically a complete listing of all the options available and what they mean, and some more examples. Those are all living there. So if you want to learn more about PSConfig than what I talked about here, you can go to that page. And that's it. So yeah, questions?
Fantastic. Thank you, Andy. So there have been several questions that folks have submitted. Some of them have been answered in line in the chat, but I'd like to get the question and answer in the recording if we can. So the first question is, when specifying hosts in the config, can the addresses be numeric or are DNS names required? And if the DNS resolution of the name changes, right? So you've got the same name, but then you go change DNS, right? And it points to a different IP address now. Is that going to get picked up, or do you have to rerun the config install? How does that work out?
Yep. So that address property, which here, let me go back to that slide too. But while I do that, so that address property can either be a host name, an IPv4 address, or an IPv6 address. All of those are valid. Also, none of those are actually ever resolved anywhere by PSConfig. It basically just plugs them into the template variables. So if you use the host name there, and then you have your test spec down here that's using this template variable, it just plugs in that string, right? There's no resolution or anything like that. So if your IP changes, basically when that gets resolved, when PSCHedule runs the test, you should be good there. So
okay, so it's literally resolved at test runtime.
Correct.
So it basically does what one would want it to do.
Yes.
Awesome. Okay, cool. Next question. So it looks like the backwards compatibility stuff is pretty robust. I guess just to double check that there aren't going to be any gotchas if somebody's using a mix of the two, sort of the old and the new.
Yeah. So if you're pointing at some old mesh files and some new PSConfig templates, that's perfectly fine. That'll work. You don't have to point at just one kind. It'll go through each of them. It's able to automatically detect what format it is, and it'll do the right thing. So that should just work.
Okay, that's great. And then there's a question about the number of archivers you can specify in PSConfig. It looks like you can sort of have 0 or more. Is that correct?
That is correct. So if I go to my archive slide, oh, what? Oh yeah, so the archive slide. So you notice there's an object and they're kind of all keyed. So you can define multiple there, and then when you define the task, you'll notice that's an array type. You can list a bunch there. So yeah, you can have as many as you can specify. And you can even add more in with those default archives and stuff that I talked about. So yes, yep, you can very much have multiple archives. And they can be different types. So you can do Esmond and syslog and RabbitMQ and go crazy if you really want to. So
slick. Okay, cool. Another question. So how are things handled when a pair of hosts are part of more than one mesh? So say, for example, a pair of hosts are part of the same regional and national mesh, right? How does that work out?
Yeah, so it'll still do both separately, primarily because I think like a lot of like the description names and the names and stuff like that are different. So when it compares them, they still look different, and generally they're going to have the same parameters. So it basically looks like add all the options in whole when it's kind of consolidating what test it has to do. So like if there's any variation at all in any of the test parameters or metadata associated with a test, it's going to just run both. So it's going to err on the side of running too much, basically.
Run all the things.
Yeah.
Yeah. Okay. Cool. Another question: are the agents still able to automatically pull down the PSConfig from a central server and apply those changes automatically? Or do you have to like set up cron to do that or something?
Nope. So the agents are actually just kind of independent daemons that run on their own on the system. So basically, it works. The schedule's basically the same as the agent. So I think by default, they'll check remote meshes every hour. You can change that with configuration. If there's any changes to the local files, like you add a new template or you remove a new template, that'll get picked up within 60 seconds, and it'll update things accordingly. So yeah, that still all automatically happens. There's no special cron jobs. And when you do the install or you update from MeshConfig, those daemons will all get set up. So
nice. Okay, excellent. Any last questions from anybody out there? Going once, going twice. Okay, thank you, Andy. This has been really, really great. I will get the recording processed, and we'll get that posted along with the slides. Thanks very much for everyone who attended, and we'll see you at another Brown Bag in the future. And thanks again to our speaker, Andy. Thanks very much.
Yeah, thank you for having me.